In today's video, we're going to be talking about the fact that when you heat something that's made of metal up, it heats up really, really fast. But when you heat up water that's inside of that metal, like a metal pan, it does not heat up as fast, okay? And the reason that that happens is because of what's called specific heat, okay? Specific heat, sometimes they call it specific heat capacity, the same thing, is a number that tells you how much heat it takes, the amount of energy it takes to raise a 1 gram of a certain substance by 1 degree. Okay, for example, let's look at two different numbers here. Okay, iron, for example, has a specific heat of 0.451. That's a pretty low specific heat. And what that means, it means it doesn't take very much heat. It only takes 0.451 joules is the unit that we use for energy. So it takes 0.451 joules of energy per every gram to raise the temperature by 1 degree. Whereas water, on the other hand, has a specific heat of 4.18. Okay, notice that water has a specific heat of almost 10 times that of iron. Okay, that's a really, really big difference. So when you boil water on the stove, again, the metal gets really, really hot really quickly, but that heat that's transferring to the water does not heat up the water as quickly. And the reason that this occurs is because water has a bigger specific heat. Okay, obviously the amount of the water also is important, okay? If the mass of the water is much, much higher than the mass of the pan, then that's going to affect it as well. Okay, and so every single substance has a different specific heat. So that means that the amount of energy that you transfer to it will not result in the same temperature change. Okay? That's why you heat up the pan and you boil the water. If you stick your hand in the water, you're going to be like, ooh, wow, that's hot. But if you touch the metal, you're going to burn yourself pretty bad because the metal is going to be really, really hot. Okay? And so specific heat is really, really important. Okay? Think about it in terms of like the river or a swimming pool. Okay, on a hot day, if it's been cold out, on a hot day, your pool isn't immediately hot and the river isn't immediately hot. Okay, and that's because, again, it takes more energy because of water's very high specific heat. It takes more energy to heat up that water than it would a piece of metal. You know, you have a piece of metal sitting on the ground on a really hot day, that piece of metal is going to get really, really hot because, again, it doesn't take very much heat, very much energy to heat up that iron. Whereas water, it does. But that also means that water holds on to heat a little bit better too. And that's why in the fall, when it starts to get cold outside and you go jump in the river, you're like, wow, the water's still pretty warm. Okay, that's because of that same specific heat of the water. So two things that really matter here are what's the specific heat and then how much of that stuff do you have? A little bit of water will boil pretty quickly. Okay, but you have, a gallon of water in a really hot iron pan. It still is going to take a while for it to boil. So specific heat is important. The mass of the substance is important. And what that leads to is it leads to this equation right here, which is Q equals mc delta T. This is an equation that is given on the AP exam. And Q is the heat, is how much heat is transferred in this process. And then M is the mass. C is what we refer to as the specific heat or specific heat capacity. And then delta T is the temperature change. Now remember, whenever you talk about the temperature change, it doesn't matter whether you're in Celsius or Kelvin because the change is the same. If you go from 0 Celsius to 20 Celsius or 273 Kelvin to 293 Kelvin, see how both of those are a temperature change of 20. So let's look at an example here. So again, the amount of heat transferred, the amount of energy transferred, which again we usually just call the heat, is equal to the mass times the specific heat times the temperature change. Okay, so let's look, and a lot of times, guys, they ask you questions about these that don't involve math at all. They simply involve logic, okay, I have to think about all three of those variables. So let's look at a couple of examples from that. So example 1 says water has a specific heat of 4.18, iron's 0.45, like we just said earlier. When 10 grams of iron at 100 degrees Celsius is added to 10 grams of water, So we've got 10 grams of both. 10 grams of iron and 10 grams of water, which means the mass in both of those are the same. Okay? Now, the iron's at 100 degrees. The water is at 20 degrees. Okay, which of the two will experience the greater temperature change? What you have to understand here is that Q of the water is going to equal Q of the iron. The iron is hotter, right? It's at 100 degrees. The water's colder. So the heat is going to transfer from the iron to the water. And when it does that, the amount of heat that the iron gives off, I'm going to put a little negative sign in front of this here, okay, because the amount of heat that the iron gives off is equal to the amount of heat that the water is going to absorb. And so those Q values are the same. Okay, and so we we can kind of just logically think about this. Okay, water has so if their masses are the same, and water has a much, much higher specific heat. Again, mathematically think about it, and these two values have to be the same. So we have MC delta T for iron, and then we're going to have MC delta T for the water. Okay, the masses are the same, so those cancel out. So it's really the specific heat of the iron times the temperature change of the water is equal to the specific heat of the water times the temperature change of the water. So these are both iron, these are both water. Okay, if iron has a specific heat of 0.45 and water has a specific heat of 4.18, in order for those two values to equal each other, think about what the temperature changes must be. Okay, in order for these to equal each other, this temperature change must be much, much bigger than this temperature change. Because 0.45 times, let's say, 60 is going to equal 4.18 times what number is going to equal that same number is a much, much smaller number. Okay, if the C for iron times the temperature change of iron is equal to the specific heat of the water times the temperature change of the water, again, and this C here is 0.45, and this C is 4.18. Again, think about these numbers here, what they have to be in order to be equal to each other. Okay, and so therefore, the iron temperature is going to change much, much more than the water is. The iron's going to drop a whole bunch because its temperature change must be really big, whereas the water's going to go up just a little bit. Okay, so when you put them together, which of the two will experience the greater temperature change? Absolutely the iron, okay? And the reason is because it has a lower specific heat, which results in a greater delta T change in the temperature. Okay? So the iron's going to change more. How much more? Well, without doing some math, we don't know. So we would have to do some math. But again, we can approximate with the numbers that they give us here. Once they're together and the temperature is the same, is it going to be 100 degrees? No, that's way too hot. Of course it's not going to be 100 degrees. Okay, is it going to be all the way down to 20 degrees? Okay, again, of course not. It's not going to drop all the way down to just the regular temperature of the water. So it's either got to be 35 or 85. But we just said that iron's temperature is going to change much more than water's is. So iron starts at 100, the water starts at 20, but the iron's going to drop much, much more than the water is. So the correct answer would have to be 35 degrees. So what you should learn from that is that the smaller the specific heat, the greater the temperature change when Q is the same and M is the same. Okay, when the mass and the amount of heat transferring is the same, then the temperature change will have to be greater when you have that smaller specific heat. Okay, I'm going to make another video and we're going to look over some more examples with this.